All right. Welcome. This is CS 5610. Hopefully we're in the right place. My name is me email at j.anunzi@gmail. Or you can use the university emails. They all point to this, right? But it's better if you send me an email from Northeastern email, because I have a filter. I get way too much email. So I have a filter so that all emails coming from Northeastern get a priority. Okay, so don't email from me from Gmail or from other places. It might get lost. So please use Husky or any university email. So this is CS 5610, right? So this is the graduate version of web development. I usually run both at the same time, and we have to make some changes so that we can run it at the same time. There's a website for this. The website is here, portal CS5610 online, rhcloud.com. That automatically takes you to the portal side of this. And here you'll find all the assignments are here, all the topics are here. As you notice, this video is being recorded, and it will be available in this website at some point later today. Okay. If you see your links, if you click on the course videos, you'll notice that these are videos from past semesters, summer 2016, in the spring, right? We ran this course as well. So they're playlists, right? So they're grouped by course. So since we're only running one version of this, there'll be just one for the fall 2016. It'll be available later today, right? But usually it'll be available right after we complete the lecture. So if you want to take a look at follow me on YouTube at Janunzi, youtube.com/Janunzi. If you subscribe, you'll get a notification when a new video has been posted. Okay. Here at the bottom of the left-hand side, you have the syllabus and the agenda, right? That we're going to try and follow this semester. In the syllabus, a little bit about myself. I've been a software developer for a little more than 20 years. I teach here at Northeastern for the last 2012, but a lot of consulting on the side as well. So I'll share a lot of anecdotes from the front lines. And a lot of the material that we see here, it's not just web development, but software engineering in general. There's some principles, some best practices that I gather from having worked on this for quite a while and working on real teams. Perhaps the projects that I'm going to be working on here might not be as big as you might find in real life, but nevertheless, we want to be able to practice those best practices. When we're working in large teams, where other folks are going to be reading our code, we're going to try to make their life easier, right? Also, our code typically will be shared, will be running together with other code, right? And so we have to consider that as well, right? How somebody else's code might affect mine. How do we isolate scopes? How to make sure that we're not bumping into each other, not stepping over each other's toes. So a lot of the there'll be a lot of overhead on how you approach solving certain problems. If it's just yourself and just one-man team, perhaps you would approach it one way, but when you're in a large team, you approach it a different way. So a lot of structure. You might, oftentimes you might find yourself, why are we following this such rigid way? We find that this is one of the better ways to approach large problems with large teams and collaborate. And it's usually when you structure, everybody knows where things are. It's easier to find things, and you have a mental model on how your solution is structured. It's easier to, it just improves the overall performance of the team, right? So contact info. So here's my my phone number. This is my personal phone number. Please don't. Well, it's a YouTube now. But if feel free to call me. That's the best way to get a hold of me. By phone or text me. I'll just leave me a message. I'll get back to you. Okay. Best time to get a hold of me is noon. Well, not during class, but otherwise the rest of the week, noon time, or maybe between 4 and 7 o'clock. That's also a good time. I have a long commute. I tend to doze off. If you give me a call, you're actually helping me stay awake, not get into an accident. So please don't hesitate to give me get in contact with me. All right. Certainly, this Piazza, you should have received an invitation to Piazza. Has everybody received that invitation? Anybody not receive an invitation? Right. If you haven't, please see me. Right. I'll add you to the list. So I'm pretty good with Piazza. I have my phone app, and I'm always on Piazza and answering questions. There's 2 TAs that are also assigned that are with us. You can't stand up. There's the other TA. Okay, we're missing one TA. Huh? She's not. Okay. Anyway, so can you introduce yourself?
Yeah, my name is Rishi Abdal. So I took this course in fall 2014, and I am serving as superior for third time.
Yeah. So he's got a lot of experience working with this. So definitely thank you, Rishi, for helping out. They'll be posting office hours as well. I'll be posting office hours. They'll be posted on Piazza, right, where we're available. I am at 460A. 460A West Village H. Okay. You should first try to resolve issues on Piazza, because many of the issues that you'll have, perhaps the rest of the team might have the same issues. So please ask first on Piazza so we can answer and for the whole community. Okay. If you can't resolve it on Piazza, feel free to come to go to Rishi's. He'll keep track of who's coming, right, and what questions you might have had, so that we can address the same issues perhaps for the rest of the team, for the rest of the class. Please also come to my office hours, or I'm good on Google Hangout. We can always jump on our Google Hangout on other times that works too. Give me a call, and we can resolve either on the phone, or if we need to collaborate, we can jump on a Google Hangout, right, and try to resolve your issue. I'm on my Skype as well. Office hours I'll post on Piazza. There'll be 6 assignments. There'll be 6 assignments, more or less every 2 weeks. In between those 2 weeks, there'll be quizzes, short quizzes, in-class quizzes that very true, false, multiple choice, fill in the blanks. Just to make sure that we're all on the same page and the concepts make sense to everybody, that nobody's falling behind on some of the concepts. There's a final project, and I suggest you start thinking of a project right now. Okay. What's going to happen is that the assignments will walk you through implementing a particular project, right? Designed to handhold you project, right, and how to how to break it out into different assets, right? Client assets, server assets, database assets, right? Through the 6 assignments, we're asking you, well, do this, right? Create these pages, these stylings, these services, these database models, whatnot. And the project, ideally, you would be following along, right? After you've completed the assignment, you would repeat the same thing for your particular project, okay? For whatever you choose to do. I have a couple of ideas, project ideas. Please come see me. I'll present them as I go, maybe next week. Other than that, whatever you want. There are some requirements, some guidelines. You have to have a homepage. You have to have forms. You have to have web services. You have to have databases. So many relationships. So many. So there are some guidelines, some minimum, right? But other than that, you're free to do whatever you want. Okay. If you're within those guidelines, you don't need to ask permission. Okay. If whatever you're building, you are fulfilling those guidelines, go ahead, do whatever you want. Okay. If perhaps you want to do something outside of those guidelines, okay. You don't want to use a local database. You don't want to use MongoDB. Maybe you want to use Postgres or SQL or something else, right? The course uses NeedStack, which includes MongoDB, which is a NoSQL database. But if you insist SQL is still a valid database, it will be with us for quite a while. So that's a completely valid negotiation. You can negotiate, right? If you don't want to use Bootstrap, you want to use some other styling framework, that's fine as well. So you can negotiate, right? And I'll go into more detail on what the right now you should start right away of thinking what is it you want to do. You should assume that anything you can think of can be implemented. Okay? Imagine everything would be possible, right? Imagine you had all the time in the world and all the resources, and you knew how to do everything. Imagine that, right? And with no constraints. And then come to me, and then we can find out what the constraints are and what can you realistically do, in 2 or 3 months. What can you realistically do with technology that we're going to cover here? But it's better to think of it on constraints first, right? Pie in the sky, everything's possible. And then we can start, putting some realistic boundaries on what can be realistically. Quizzes. This is the first time I'm doing quizzes, so let's see how it goes. I expect the quizzes will be fairly simple, at least for the first go around, as I become used to using quizzes. But nevertheless, there's a homepage. You will have to have a homepage, a personal homepage. Okay, this is not the project homepage. This is a personal homepage of yourself, just presenting yourself, a little bit about yourself. It should link to everything else that you're going to be building throughout the semester. It should link to the assignments. It should link to your projects, right? It should link to your GitHub, right? Perhaps a CV should be there, a resume should be also there as well. It should be part of your resume. So, hey, something that you would be proud to show to a potential employer. Look what I can do. Okay. You're free to use templates that are freely available out there. Lots of animation. Don't overdo it. It should be classy. It should be something, again, that I should be proud to show my colleagues. So look what my folks are working on web development. Okay, so that's 10% of the grade. The assignments, there's 6 assignments. They're in total will be worth 35%. Each assignment is very explicit on what you need to do, and it hands-holds and walks you. These are all the pages you need to build. These are all the CSS styles you need to create. These are the web services. These are the URL parameters. They're very explicit, okay, on what the requirements are. And there's rubrics available for each of the assignments. But if you follow the steps, you should be fine. Late submission. Submission. We're not going to be using Blackboard. We're going to be using Blackboard very minimally. Okay. Submissions. We're going to be using GitHub to do all our work. Right. So every assignment. Because the assignments build on each other, they all are building one single project. Okay. What will happen is that you'll be building the assignment, assignment 1, and once you're done with the assignment, there should be a history of you committing all the work that you've been doing. At the end of the assignment, right before you submit, right before the due date, okay, you're gonna tag the very last commit, right, on GitHub. And you'll tag it assignment 1, assignment 2, assignment 3, assignment 4, okay? And then you'll just continue on to assignment 2, right? Without any concerns that, oh, wait a minute, should I start working on assignment 2 if I'm going to overwrite the work on assignment 1? That's not a problem, right? GitHub allows us to go back in time, yes, and go back to a particular assignment and see what you had for assignment 1, right? And recreate that on our local machines at any time, any moments. We can pull your last work and grade you. So yeah, so there's 6 assignments. They all build on each other. Okay. Let's see. There's going to be 6 quizzes, right? Again, first time I'm doing quizzes. There's multiple choice, true, false, and very a lot of just fill in the blanks. Probably no coding quizzes or anything like that, right? That will be through the assignments, right? The grading of actually building something. Project is it's the largest chunk. It's a final project. And again, start thinking about it now, right? You might have the next great idea, right? The next Facebook. If you're that successful, remember me, and I'll come work for you. Participation. So again, we're going to be using Piazza. Please participate. If somebody is making a good question or a good answer, vote okay. Thumbs up. If somebody is making a good answer, even a good question, let them know that that's a good question or not. Well, let's see what else. So on the left-hand side, not only do we have course videos, we have sections for each one of the topics. The first topic is going to be setting up your development environment. Okay. Starting today, you should start. Yes. Yeah, I changed this morning. I'll upload the latest. Right. Your first assignment. Right, you'll need to download Node.js. Right, Node.js, that's going to be our server. There's going to be a local environment, right, where you're going to be doing all your developments. Right? Once you're happy with your developments, right, you're going to push that and host it on a server, right, so that everybody else can see what you're doing. Also, you're going to be pushing your source code onto GitHub, right? So that's again, it'll be available for the TAs and myself to look what everybody else is, what you guys are doing. So you need to install Node.js. You'll need to install MongoDB. That's the database that we're going to be using for the semester. You're going to be installing for the IDE. We're going to be using WebStorm. It's pretty. It's well represented in the industry. A lot of shops use WebStorm. You're free to use other things than WebStorm. But it'd be easier for us to support you, right? If you use WebStorm, if everybody uses the same IDE, it would be easy for us to collaborate, okay? And to answer, one question or one answer from one particular IDE, as opposed to having to set up everybody else's environment differently, okay? It'll just make everybody else's life easier. So yeah, so the first assignment is to set up the environment. These are all Google Docs. Slow. Please go over it. Take a look. I'll go over this in detail. Right. So please take a look at this this setup. But basically, it asks you to download Node.js, download MongoDB, Git. If you have a Mac, you should already have Git installed on your machine. If you have a PC, there are plenty of Windows Git clients, right? So you need to install that as well. And the hosting service that we typically use, I've been using for the last couple of years, OpenShift, recently announced that they're not accepting any new users. Entire stack. So I'm going to try and resolve that this weekend. So meanwhile, start working on this assignment, setting up your local development environment. Okay, while I fix up what we're going to use to see this online. Okay, but meanwhile, you should, by the end of next week, you should have Node.js, MongoDB running locally, a Git account. You'll be able to post things on Git. You should be able to run it locally in your machine. We'll talk about posting this on a hosted environment, perhaps at the end of next week. So yeah, so it walks you through downloading Node.js, installing it locally, downloading MongoDB, and installing it locally. Some configuration that you might need to configure locally on your Macs or your PCs. Setting up Git. This is for PC, right? On Macs, you already have that. Setting up a template project. I have a on Git. I already have a template project, right? You're going to download that. You're going to clone it using Git, and you're going to have a local copy of my project, of my starting project. It's just, a very, very simple, couple of lines project just to test whether you can, write to the database, read from the database, that you have it set up correctly locally, right? And also, when you post it remotely, it also tests whether if it's working remotely, right? And I want this to be as soon as possible, so that we don't push it to the end, right? And I'm working on you've been working on your project for a couple months, all of a sudden it doesn't work remotely, right? So I like to iron that out as early as possible, get that going. Too bad OpenShift is not cooperating with me. So anyway, these are very explicit steps. Please take a look at them and try that. Have this setting up. Anybody has GitHub? Most of you should have GitHub, right? All right, so most of you have GitHub. That's great. I only ask that you create a repo specifically for this class. Okay? Or if you don't have GitHub, please create an account and create a repo, right, for this particular class. Right? So this walks you through the way you should call your repository. I'm asking that you use a naming convention so that we can quickly get a hold of you. Also, I'm asking you to invite myself and the TAs as collaborators, right, to your Git, to your repository. Right? If you run into an issue, we can quickly help you because we can clone down your repo, right? You can fix it on the repo and just push it back into GitHub, right? And so then you can pull down from GitHub and boom, you're done, right? You don't need to share screens or walk you through. We can right away help you really quick. Okay. Also, anytime you ask a question on Piazza, right? Please, right? Provide a link to your GitHub account, right? Provide links to, if you've debugged this, hopefully you've debugged this already. Links to the file where you think the problem is, right? Navigate on GitHub to that file. It says, I think the problem is these two lines. Now, GitHub allows you to highlight the lines, right? Copy the URL and send link that says, "Ooh, these are the 3 lines that fix the problem." Okay, so that will help us, help you faster. Otherwise, we're going to spend 2, 3, back and forth. Please provide your GitHub URL, right? And that just bogs down our ability to help you. Okay, so we're here to help. Please help us help you. All right. Okay. Setting up OpenShift. This whole section might change. Okay. So don't set up OpenShift right now. WebStorm IDE. So this walks you through downloading WebStorm. WebStorm is not free, but it is free if you register with a EDU account. Okay, so you'll need to create an account at JetBrains, right, with your Husky email. Right? Once you create that account, you then download WebStorm, right? And when it asks you to register, log in with with the account that you registered with JetBrains. Okay, and then you'll have the IDE will be free. Okay. It's a very powerful IDE. It allows you to debug the front end. Allows you to debug the server. Okay, and we'll please, if you run into issues that something's not working, don't just say, "Oh, it's not working." Show us that you put some effort into debugging it. Right? If you come see me in my office hours or TAs, I certainly would like to see that you step through the code, that you put breakpoints, right? You put some. I like to see some effort that you've gone through this, and you think you pointed out a little bit where the problem might be. Okay, and debugging is a very important skill that is part of the learning experience. Yes. Deliverables. The deliverables are always going to be the same for all assignments, right? The deliverables are always going to be, send me a URL to your hosted environment, and send me a URL to your GitHub, right? And for all assignments, it's going to be the same, right? Because everything is being submitted through GitHub, really. There's nothing to submit in Blackboard, right? But it just makes it easier for us to just click and boom, we're right there in GitHub and start grading you. Right? So just convenience for the TAs and myself to grade you. All right, so that's the first assignment. Please read through this. We'll go through this again next week. So all these are for the various topics we're going to be discussing throughout the semester. More or less, it's 2 weeks spent on each one of these topics. Development is going to be less, right? It's just going to be, well, today and next week, setting up the environment, or maybe less. But each one of these also has lectures, assignments, and whatnot, and also examples on how to on using that particular topic, right, in real life. So why is this not showing? Is this local? Oh, there we go. Some of these are pieces, snippets of code that are being hosted. JS Fiddle allows you to quickly put something together, at least on the front end, right? Some HTML, some CSS, some JavaScript, right, and quickly demonstrate how this piece of code works, and do some live coding, and you can also play around yourself. So we're going to go through each one of these as we go, but I encourage you to go through this before class, right? Come to class already having gone through some of these, right? So that we can move quickly, do some coding here, some sample. I love to code here. So I'll quickly go through the examples and then jump into some live coding. Typically what we'll do is that we'll get you started assignment, right? The assignment might ask you to do, I don't know, 10 pages. I'll get you started doing 2 or 3 of those pages, right? And then I'll say, okay, well, you should be able to extrapolate from what we've done here in class, these first couple of pages, you should be able to extrapolate and continue finishing up the last, the other 7 or 8 pages. Okay, following the same techniques that we discussed in class. Okay. Also, each one of these topics has a video that has been pre-recorded. These are not YouTube videos. They're a little. They're not live presentations, right? It's me talking into a mic, so I sound a little more robotic. In my YouTube video, it's just me. But nevertheless, please go over those videos, right? It covers a lot of the topic, so that again you come prepared for class. So, for instance, for Monday, I hope you go over already the videos that are there that talk about MongoDB, talk about Node.js, talk about the various topics. So, for instance, here in the lecture, if you could go over the videos on how to install Node.js, how to install what Node npm and the Node's package manager is, and how to install Git, OpenShift. Well, I guess I'll need to change that. OpenShift. This video in particular is has no audio. Some of the videos might not have audio. That's fine. They should have a text at the bottom, perhaps, or just walks you through what to do, right? But very few don't have audio. And the assignment, right? The assignment. So please go over those. Let's see. Let's look at the agenda. So this is the agenda for this semester. So today's Thursday. So for this week, I guess this week and next week, we're going to be setting up the environment, talk about the schedule, present introduce the course, get you going with Node.js, with MongoDB, the IDE. We'll introduce what mean stack is, right, as one of many frameworks, but it's in vogue right now. It's a lot of jobs on mean stack. So we're gonna go over that, and what are the constituent Angular, Node.js. And we'll talk about MongoDB. So this week we'll set up we'll create today a toy mean stack application, just to give you a feel for what it looks like. Something that can be done in class. Is there no clock here? No clock. Something that can be completed in a lecture. Right? Just to give you a feel of what the mean stack is. So setting up the environment and introducing to the stack. The next couple of weeks, we'll introduce user interface development. So we'll talk about HTML, CSS, how to style things to look professional. We'll talk about how to deal with responsive design. That's the largest, fastest growing user base is people are accessing content through their tablets, through their phones, through smaller screen, and certainly want to cater to them since that is going. This is the future, right? That's where people are actually going to be visiting our website. So certainly we want to cater to that demographics, right? Even before we even consider desktop, right? Since they are becoming the minority, right? Desktop applications. So certainly we want to introduce the philosophy of mobile first. First, we'll consider mobile applications, and then obviously, if you have more space, larger screen, we can certainly, show more things, but not necessarily because it's bigger. We can just throw at it just a whole bunch of other things, right? Mobile first is a nice philosophy that forces you to really think about what it is that you want to show the user, right? It forces you to think what is the most important thing, right? So that because you have such a small real estate, what do you really want to show at the top, right? And even considering people using just their thumb, right? So how do I make it easier for them to navigate and use my website, right? What's the most important thing? So it forces you to think how to break up an application, about the information that you want to convey, and then once you think about bigger screens, you can be a little more relaxed and says, okay, well, not only am I going to show this information that I already have there, but what else could I show that is also useful, right? That can inform the application that I already have, right? So we'll talk about that, and we'll talk about how various frameworks such as Bootstrap achieve responsive design, right? Certainly, we don't want to rewrite a whole website for just various devices, right? We want to make it as adaptive as possible. The next couple of weeks we'll be introducing JavaScript, AngularJS, right, and how they fit into the larger model view controller frameworks. Right, there's a whole bunch of different model view controller frameworks. AngularJS happens to be one of the more successful ones, one of the more popular ones, but they all follow the same philosophy of breaking up applications into buckets, right, of responsibility, right? Where am I going to do the logic, right? Where am I going to do the modeling? How am I going to render this? How am I going to lay it out? They're three different aspects of building an application, different concerns. You want to break them up and deal with those concerns, right, in their own right. So we'll introduce JavaScript at this point as a programming language that will allow us to program the browser, interact with the browser, and be the first line of interaction with the user. As the user clicks and drags and interacts with the application, JavaScript on the browser will allow us to immediately respond to those interactions. We'll see how model view controller forces us to think in a particular and AngularJS in particular, following the model view control philosophy, forces you to implement applications in a particular framework, in a particular way. To think in one particular way. It's not just whatever I want, right? It has to be done in a particular way. Some people find that too restrictive, right? But again, in larger applications, restrictive is good, right? You can't be just anything goes. So notice I have quizzes here in between assignments, right? So the assignments are going to be due. And I'll have a quiz 1 before the first assignment is due. Right? So typically it will be a quiz 1 week, the assignment will be due the next, right? And then a quiz, and then the assignment, then the quiz, and then the assignment. Right? So I'm staggering them. So they're 1 week apart. Okay. And typically what we'll do is we'll just go. We'll have questions about all the material that we've seen in that particular module. Right. They're not cumulative, but nevertheless, sometimes there are some dependencies between the topics. But typically they'll focus on that particular set of topics, for instance, user interface or client-side development. Then we'll do server-side development. I mean, we will have a server for all this time, right? We will have a server. It'll be a very simple server, right? Enough to host our Angular applications, our HTML, our CSS, right? We'll come back to this later on in the semester when we, in the week 7 and 8, we'll come back to side development because we need to services, right? Being able to save the data, right? All this time we've been interacting with the application, but nothing's being saved, right? Every time I refresh the page, poof, everything's gone, right? Because there's no way. But we want permanent saving, right? We're going to be able to shut down a machine, come back tomorrow, log in, and there's my data, right? And the only place to really save it is back on the server, right? So we need to be able to post the data to the server, retrieve the data from the server, update the user interface, right? And do all sorts of pride operation, right? Being able to create things, update things, read things, delete things, right? You'll be able to interact, and the only place to put it really is on the server. So we'll come back 2 weeks, and we'll spend time on revisiting Node.js, introducing Express, being the Node.js. It's the E. It's the E in mean step. It's that E. It's one of the more popular Node.js modules, right? That allows us to very easily set up a web service, create HTTP logic, right? To respond to posts from the client, or gets, or puts, or deletes, right? So what Express is going to do is it's going to allow us to very easily create web services, RESTful web services that will receive data, store it, right, and send it back and for the client to render. So we'll revisit and talk about web services then. It'll also give us a chance to talk about interacting with third-party APIs, right? Being able to connect Wikipedia or tons of third-party APIs are out there, right? IMDb or all sorts of these free online databases, which I strongly encourage you to start investigating what's out there, right? Depending on whatever topic interests you, right? Typically, whatever topic interests you, there typically will be some free API out there, right? That you can start querying it, retrieving data, and interacting with it in your. Right? So we'll visit those APIs as well here. Towards the 9th and 10th week, we'll talk about database development. Where to store this data, right? It needs to be stored in a database. If you feel that in your project you prefer to use Postgres or MySQL or any other database, that's fine. That's legitimate. It'll be okay. But in class, we're going to be using MongoDB. So we'll introduce NoSQL as an umbrella term for these next generation databases that, as the name suggests, don't use SQL, right? Don't use tables. Don't use foreign keys and primary keys. It's it's a completely different way of thinking about databases, right? Modern databases solving modern problems, right? Databases were invented quite a while ago, and there was solving problems from back then. Today, the databases, our needs for databases are different, right? Every time I pick up my phone and I just move it around, I'm creating a stream of data, right? And somebody's storing this data somewhere and relating it to something else, right? And they're data mining all this data and trying to determine my behavior and predict my my spending patterns and all sorts of and relating it to my driving and relating it to all sorts of things, right? So the data that we're collecting today is just it's exponential, right? And it's just generating more data than we will ever be able to process, right? So there's a lot of techniques on how to humongous data, right? All the statistics that can mine all that data. So today's requirements for databases are completely different from back when SQL was first came out, right? So relational database just doesn't cut it for a lot of these new requirements, right? Being able to have it redundant, being able to be geographically located, right? To be can sustain failures, right? That you have redundant across many geographical regions, distributing a whole bunch of servers, right? And so there's a lot of new, really cool things that the SQL database, NoSQL. Some data model before, if you've done 200 or 3200, you should be okay. But I'll assume that you've done maybe some UML diagramming. You understand one-to-many relationships, many-to-many relationships, like foreign keys, primary keys. I'm assuming that. If you don't, if you haven't seen these courses, please see me. Right? Perhaps I can grab a couple of you and we can do maybe clinic. or meet together in my office and we do a refresher on some of these concepts. Data model. There's a lot of data modeling in this class, right? The next couple of weeks, we'll talk about right before Thanksgiving. We'll talk about how to secure your application. How do I log in or use third-party authentication, such as how do I log in with Google or log in with Facebook, right? And how do I manage users, create users, or allow users to do certain things depending on what role they are, right? Create access control lists and whatnot. So how do you manage users, right? So we'll spend some time. We'll use Passport.js for that kind of implementation, and then we'll have week 12. We're just going to meet on Monday. Thursday is classes there. When we come back from the Thanksgiving break, we just have one more lecture, right, on dynamic server pages. But notice there's no assignment for this. There's no assignment for the last one. Okay, but I encourage you to come anyway to the lecture. But my expectation is that by week 13, you'll only be working in your projects. Well, my idea is that you'll be working all through Thanksgiving, and that last month will be just finishing everything up, right? But I would assume that by that Sunday of week 14, December 11th, right, your project should be done, right? So it's the first 2 weeks of December, right? So you should have everything done by maybe the end of Thanksgiving, and just tweaking here and there, final adjustments, right? Fixing a couple of things, maybe just hand it in the next week or so. Maybe debugging or fixing a couple of things by the end of second week of December. Week 15. Week 15. I'm going to be evaluating projects. TAs and myself are going to recluse ourselves and just that week or two, just grading, right? We're not going to be available for help. If your project's not working, I'm sorry, but it's a grueling process grading all these projects, right? So we're not going to have time to help you fix something there. So if you need help, please see us before, right? Before that due date, okay? We won't be available after that. Yes. It could be 2 or 3, right? But no more than that. Let's see. What else? All right, so that's the agenda. Any questions so far? That's the thing. See me. You should know by early on whether it's so don't wait to the end to know. Ask me. But yes. Yeah. No, you don't. No, grouping is not. All right. All right. So let's. I think we have plenty of time to do some coding. It is recording, yes? It is recording, good. All right, so let's do some coding. So what I'm going to work on today is I'm going to talk about the mean stack, right, and use Node.js to implement a very simple mean stack application, right? So I would need to install Node.js, and you can download Node.js from nodejs.org. Right? It is going to be our server. Right? It's going to be the machine that's going to be hosting our content. right? Our static content, our dynamic content, and you can download it and install it for your particular environment, right? In my case, it's Mac OS, so it gives me immediately chances to download from Mac OS. I've already downloaded, I already have it on my machine, and so from the command line, I can test whether Node is up and running by just typing Node. Okay. So Node is added to your path as an executable, right? And Node, the only thing Node is just an interpreter for JavaScript, right? All this time we've been using JavaScript for programming on the browser, right? It's the language that allows us to interact with the browser, right? And open pages or modify the page dynamically, do some animation, do things on the browser, right? What Node is just the same interpreter, but at the desktop level, right? We can write JavaScript, right, and execute it using Node, and then give it a JavaScript file, right? So that's all Node is, right? It's an interpreter for the desktop, and it's become very, very, very popular in the community, right? Software development community, especially in the open source community, right? So much so that there's lots and lots of really cool modules that the community has been making available to the rest of the community. Okay, just like any other platform, Java or .NET, those platforms are only as interesting as the libraries and the tools are available to make use of that particular platform, right? Node.js is the same thing, right? It only became interesting when such a module such as Express, right, became available and made it very, very easy to set up servers, right? Just with a single line, 2 lines of code, I can have up and running an HTTP server, right? And I can start do it fairly libraries available in Node. Okay. Another executable that will be installed when you install Node.js is npm. npm stands for Node Package Manager, right? As the name suggests, allows you to very easily install new libraries, right, that are available in the Node. Okay. One of the ones I'm going to be using quite often all throughout the semester is the Express library, like Express module. And we're going to install it locally, so with just a couple lines of code, you can set up a running HTTP server. Right. So npm we're going to use quite often as well. Okay. So to get started, I'm going to create a directory under the 2016 over here. So let me go back up. Fall. Okay, so I'm going to create here a little application, simple application that allows me to do maybe like a little to-do list, right? That I should be able to create a new to-do, maybe edit that to-do or delete that to-do, right? So do all the various CRUD operations with that to-do task. Okay. So let's create a directory where to-do. Right? And I can go into that directory, and there's nothing in there, right? So to make this a Node project, right, we can use the npm command to initialize this to be a package, right? Something that we can use. So we can say npm init, right? And what the package will take as a default name for this package will be the directory, right? The directory that we are currently in. So we're in the directory to do. It takes that name, but you can change it. By default, it's version 1. You can give it a description, a simple to do Node.js app. Okay. Entry point. You can if you create this as being a module, just like we're going to be using somebody else's module. You can create also modules to export to someone else, right? And the way it's exported is through a JavaScript file called index.js, which we're not going to use right now, right? But that's what it's useful for. So you can have other folks reusing your components, right? Your modules. We're not going to use it. You can also create put this in as part of a test environment, so you can test your code. We're not going to use that either. You can say that where is this being hosted on Git, right? So that it can be linked. If you publish this in the package manager, right? There's a library that's up in the clouds, right? At npm.org. You can put keywords here for other folks to be able to find you, right? If they're looking for the next best package manager that allows, I don't know, image processing or something, right? So you put keywords here. So we'll do some ToDo tutorials. If I can spell. Author, it's me. License. There's all sorts of licensing that you can provide. MIT license or whatnot, or GNU licensing. Is this okay? So what it does is it generates a single file, package.json, right? So you notice that it's using this nomenclature here that is we refer to this as JSON. JSON. It's a JavaScript object notation, right? It's something that we're going to be using throughout the semester, right? It's how we are going to represent objects, right, in this class. Right? We're going to be sending objects back and forth. We're going to be creating objects, destroying objects, modifying objects. These objects, whenever we talk about these objects, is these objects right here, right? So this package, if we do a more on the package JSON, we have a JSON object. So the curly bracket opens, right? That means that this is an object, right? Objects have name value pairs inside, right? We have attributes, and then we have values. We have these colons. It says this is the attribute, it's the and ToDo is the value. Version is the attribute, and the value is 100. Description is the attribute, and so on and so forth. Make sense? And they're all comma separated. We have objects that can contain other objects, right? For instance, this is the outside object. Here we have another object. Scripts is an attribute whose value is another object. See that? So we can have nested objects, right? And this can be arbitrarily nested. Here, or we can have an attribute. We can have an array inside an object. So we can have an object that has arrays that have objects, objects that have arrays of objects indefinitely ad infinitum, right? So we have here keywords, strings. These are literal strings, right? These are not objects, just literal strings. And the quotation marks here, they're all double quoted. Right? Make sense? Everybody good? All right, so we have this package JSON, and that's all we have. We need a server. To get a hold of a server, we're going to use a very popular Node.js a module called Express. Right? So if we go to Express libraries, it's taking a while. Right? That makes it very, very easy to set up a running server. Right? We have the API reference, which I strongly encourage you to go over this API and become somewhat familiar, at least to know that it's there, right? How it's organized. Whenever you need to come back to it, come look here in the API reference, right? So let's go to the latest version of this API reference, and here they give you a couple of examples of what you might use for creating an Express server. Okay, so here's an example of creating an Express server. Right, you create this JavaScript. This is JavaScript running on a desktop. Require is the equivalent on other languages such as import or include, right? Where you're referring to other libraries and you're just including somebody else's work, right? It's a way Node.js allows you to break up large projects into smaller constituents, right? So Express is a library I want to use, right? So this code, right, creates an instance Express right here And then here we use a constructor. We run that constructor. It's an instance of that. Right, all the functionality is accessible through the instance. We can say app dot, and there's a whole bunch of functions that we can access. Yes? Right? So let's do that. Let's copy this. Right? So let me open up this directory in an IDE so I can do my coding. All right, let me open. And where is it? Let's see. WebStorm. I think it's NEU Webdev 2016 Fall ToDo. There it is. Okay, open. I'll open it. A new window. So there's package JSON server. Okay. And so we're gonna put in here the code I just copied. Yes. And that's it. Those 2 lines of code. I have a server. It's not doing much, but I do have a server instance. Okay. If I try to run this, I think I'm not in the right place. Fall ToDo. Uh-oh. Wait, NEU Webdev 2016 Fall ToDo. Huh? Close project. Open again. Hello? Yes? No? Where did you go? Are you awake? No, you're not awake. WebStorm. Open. Okay. All right, so let's see. Was it here? That's it, I think. This is the one. New window. All right, there it is. So ToDo, there's the package. That's all we have. Let's create a file. Yeah, that's why I was weird, since I don't remember creating that server.js. Okay, so let's create a server.js, server.js. And we're going to copy in there. There we go. Okay, and I can try to run this from my command line. Okay, there's my server.js. I can make sure that it's there. Give it the server.js. Yes? If I run this, notice that it'll complain. It says, I can't find Express. So what's this module you're referring to, Express? I can't find it in my path. We need to install this particular library. And the way we install it is through using npm, right? And npm, the Node package manager, you can give it the package that you want to install, right? Now we can say node install Express, okay? If I do that, it's going to go fetch and download that library. It's going to copy it locally on a file system, right? If we do ls, oops, sorry, you'll notice it's a new. It installs all the packages that it downloads from the package manager. So we can do ls a node, and we'll see. Notice that it not only does it install Express, but any dependencies that Express has on other modules, right? It downloads and installs those as well. Okay. So if I try to run the Node.js again, Node.js server, notice that it ran. It didn't complain. It didn't do much. It didn't do really anything. It just instantiated, but it then quit. Okay. But it's no longer complaining. Okay. Now this install command that I just did here worked fine locally, right? But save. right? What that does, I'm going to do cancel. If you took a look at the package JSON, notice that it has name, version, description, names, scripts, keywords, and so on and so forth, author, and license. Okay. If we do an install and do a -- save, okay, and you should always do a -- save. If I do that, it's going to reinstall. That's not the point, right? The point I'm trying to make is that if I do a more package JSON, notice that now there's an additional entry in the package JSON. You see that? As the entry says that this project depends on another. This project cannot run unless you have Express installed. Make sense? Okay. The importance of this is that when you deploy this, right, on a hosted environment, right, the hosted environment is not going to know that you just, unless you put it in the package JSON, right? Your hosted environment is going to open up your package JSON. It's going to read it. It says, you need Express. All right, let me go fetch that for you and I'll install it, right, so that it's part of the deployment. Make sense? If it's not in the package JSON, it will not deploy remotely, right? It'll work locally because you have Express deployed locally, but it will not work remotely because you don't have it. Lots of questions on Piazza. It's working locally, but it's not working remotely. The first thing I'm going to ask you to do is show me your package JSON. Okay, that's the first thing I'm going to ask you. Send me a link to your package JSON, right? And I'm going to check to see if you have the required libraries listed in that package JSON. Make sense? Okay. Notice that if I go to the directory and I go into that directory, NEU Webdev 2016 Fall ToDo, that node modules, if I blow it away, move to trash, node, it complains because it doesn't have Express. Yes? So in the remote environment, what's going to happen, right, is that your server, right, where you're deploying, part of the deployment process is to do the following. It's going to do node install. We use node install, right? We use to install Express, anyway. But if you say node install with no argument, with no particular package, right? If you only say node install, what's going to happen is that it's going to read your package JSON. It's going to look for your package JSON. It says, let me see what you need here installed. What are your dependencies, right? So when I do it, maybe not. npm install. I'm sorry. npm install. npm install. It's going to read your package JSON. It's going to see that you're depending on Express, and it's going to install all your dependencies, right? So now, notice that node modules is back with us. See that? Right? And if I run the server, it's not complaining anymore. All right? Everybody good? That's what the TAs and myself are going to do, right? When you have a problem, or when we're going to grade you, we're going to clone your project locally, yes, in our machines. We're going to type node npm install. Right? It's going to install everything. We should be able to replicate your environment locally. We should be able to run and test your, right? If it doesn't deploy correctly, it's because you either forgot to do something in the package JSON. That's gonna be points on. Right? So make sure that this installs locally on your machine, and that we're going to be able to install it. Yes. Right. Yes. So we don't need to you don't need to. Right. Yes. Thank you very much. So these everything that's in node modules, everything that is under node modules, makes no sense to put it in a inside of a Git repository, right? Because this can always be recreated. Right? There's no point in having bazillions of copies of Express. You can always replicate it by running node install, right? So one of the things that the first assignment asks you to do is to create git ignore. Okay, create a git ignore. Okay, will allow you to, there it is, git ignore, right? Where you can put here files, right, that Git should not push to the repository, right? So the TAs and myself should not find in your repositories Node_modules. That in your repository. Okay, thank you. So in git ignore, you would put something like, you would say Node_modules, meaning ignore the directory called Node modules. Do not push this into a repository. Okay. Other things you're going to put in here are .idea, right? Your IDE creates a folder. It's a hidden folder, right? Where it puts all the preferences, all your configurations and whatnot. That also is irrelevant to anybody but yourself. Okay, so that too should go in this git ignore, right? I don't want those XML files, right, in the source control. Okay, so this is a very dummy server. It doesn't really do anything. Let's continue. If you continue a little further in the API reference, they give you something that's a little more interesting. Okay, the same 2 lines as before, same 2 lines, but they give you these additional lines. Give you these additional lines. What this says is that create a server that listens to port 3000. 3000 is a very popular port for developers, right? Node.js developers. It's a very popular port, for your development purposes. It also declares a listener, right? An HTTP listener. Right? I am going to listen for an incoming GET request at the root. Okay, that's what that line says. If there is a request, if there's a GET request at this particular root, this is what's going to execute this function, right? This is a callback function, right? Some of you might find this a little bit disconcerting. A function within parentheses, right? We call those anonymous functions. It's a function that has no name, right? It's a throwaway function, right? It's a function that cannot be referenced, right? Its only existence is within this this line of code. Yes. Right? And I'll give it a name. So handle root request. Okay? And I'll actually create a function with that name. Okay? Same thing, right? If an incoming GET request at the root, that's the function I want to execute, which is declared down below. Yes? Right? I find this to be much more readable, right? Especially if you have lots and lots of routes. We call these routes. Right? This is you're configuring here a route. As a request comes in with a particular route, a path, a query, and whatnot, I'm mapping this route to an executable. Lots and lots of routes. Okay, some posts, some puts, some gets, some deletes, right? It's much easier if you group all those routes at the top, right? And then you implement all the functions down below. It makes it much, much easier to read, right? And I'll ask you to please follow that pattern. Okay. So what does it say? If an incoming slash comes in, this function is going to execute. It's going to receive as part of the call. It's going to receive these 2 objects. What's happening here is that the server is receiving a slash request, right? The server intercepts that request. And when the HTTP request comes in, it parses that request, right? So for instance, if you have here the server, right, and here's the browser, and the browser creates the request, the server intercepts that request, right? And it parses it. In that request comes a lot of information, right? The cookies, right? The IP address from where it's coming, the timestamp, headers, bodies, HTTP headers, HTTP body, right? JSON object that might be passing. So there's a lot of things that come in that request, okay? So the server parses all that, right? And it creates any data that might be part of the request, right? Any query parameters, any path parameters. And you can extract lots and lots of information. The IP address of where this is coming from, timestamp, all sorts of things, right? Any file uploads would be here as well. Okay? Any form submissions will be here as well. Okay? Also, it provides you with a means for responding, for generating a response back to the browser. Okay? Your response might be, a plain text, right? Or it could be a file that you're reading from a file system that you want to stream back, right, from downloading. It could be an object that you're reading from a database. It could be an array of objects, right? It could be all sorts of things, right? So here, this one, what's doing is just sending a plain text response of hello world. So you could refer to this as the hello world of Node.js. This is the hello world sample of Node.js hello world example. Yes? So let's try it out. Let's run it. So we could run it here, Node server. Notice that it's blocked now. See that it never came back? Before it used to, right? Because right now, the server is running forever until I kill it, right? It's forever waiting for that incoming GET request, okay? At port 3000. So let's, localhost is this machine, right? Which also can be referred to as the IP address 127.0.0.1. Localhost is fine. Notice that 3000. I'm using 3000 so often that it's the first thing that comes up. If I hit it, notice that it says hello world, right? Notice that this is the equivalent of this slash, right, at the root, right? So it says hello world. If you don't believe me, here I can change it, right? I can change this and say hello world, right? And if I reload, it doesn't work. Maybe I'm fooling. Well, actually, any changes that I make to the server, right, unless I restart the server, any source code modifications, I need to restart the server. Any client-side modifications, I don't need to restart the server. Right? If I make changes in JavaScript on the client, or HTML, or CSS, I don't need to restart the server. If I make changes to the server, I do need to restart the server, which I did. I made some changes to the server. So I'm going to stop it, and I'm going to restart. If I refresh, notice that indeed we did change it, right? Now that URL that I'm using right now, it's slash, right? It's a bad idea to map the root to something so trivial. So let's map. It says I don't have a route for slash hello. There's nothing mapped to slash hello. So I don't know how to respond to you, right? It's not listed in my routes, okay? But we can change that. We can change it to be hello. We're going to change the route. Instead of listening to just slash, we'll change it to slash hello, right? So I made some changes. I'm going to stop and restart the server. Here, if I refresh now, notice that it is mapped, right? Oh, now it's mapped to that response. Okay, everybody okay? All right. Okay. All right. We'll come back to the server a little later. Right? There's lots and lots of things we need to learn, but at least we know we have a running server. Right? We have a running server. What we want to be able to do is be able to implement, a really tiny, minimal mean stack application, right? So let's do. First of all, we need to be able to, host HTML and CSS and JavaScript files, right? We don't have that yet, right? The only thing we have is a hard-coded route mapped to an executable function, right? To what we want to be able to do is to perhaps, declare here a directory, dedicated directory, where we can host all our static content, right? All our HTML, all our CSS, all our JavaScript, right? All, from the point of view of the server, that's all static content. It's just ASCII, right? It's always the same ASCII code, right? It doesn't change. From the browser's point of view, it's not going to be static, right? It's going to be dynamic, right? JavaScript is going to be manipulating the HTML, right? So from the browser's point of view, it's going to be dynamic. From the server's point of view, it's going to be static. Yes? Yes. Now you can name it whatever you want. OpenShift requires that you call it server.js. But you might not be using OpenShift, and Heroku or whatever we end up using might have other naming conventions. But that's a very common name, right? Or app.js is also a very common name. Yeah. Until we decide, let's use server.js. All right. Okay, so if we want to host HTML files, we need to be able to host them. So to do that, here's the line that allows us to configure, right? Configure a particular directory that's going to host all our static content, right? So we're going to grab that, right? And we're going to configure right here. We don't really need this anymore, right? This was just for us to test whether this was working. I'm just going to leave it just an example. Here I'm going to configure. Actually, no, I'm going to put it right here. This says I'm declaring public as it's going to contain all my static content. Okay, so that now anything that I put in here, or anything that I drop in this public directory will be accessible, through the / and then I can navigate the public directory, right? So for instance, if I do here an index file and say index, right? And in here I say hello, hi from index page. I'm going to restart the server. All right, so instead of restarting the server every time here from the command line, right? Instead, what I would prefer that you do is to create a configuration. Right? Please have a configuration. The configuration is going to allow you to, among other things, is going to allow you to step through the server code, right? Debug the server, right? So declare here over here. You go here and say I want a new run configuration. I'm going to say I want a new Node.js configuration. I'm going to call it server. That it's already using the correct Node version. I have several versions. It is in the correct directory, right, where my project is. There, I want to run the server file, server.js. So instead of typing at the command line, I'm going to say OK. Now I can select it server and I click run, right? So now it's running. See that? Be careful that running server, if you try to run it again, is going to complain saying, hey, there's someone already listening at port 3000. I can't run. Okay? So be careful. You'll need to kill the previous one or whatever. So for instance, if at the command line, if I run it, see that? Complain. There's someone already listening at 3000. Okay? So be careful there, because you might already have something running there. Okay. So anyway, so let's go back here. So this still works, right? Hello world still works. But now we have an index page, right? Notice that now it's going and fetching an actual page, right? Copying that over, right? And then the browser is rendering the HTML in the browser. That pretty good? Okay. Also notice that if I don't ask for anything, index, notice what happens. It still renders the index page. See that? Right? That's the default behavior. The default behavior is when we when you navigate typically that default page is index.html, right? But every server can be configured differently, right? The default configuration, the default page, if you don't ask for anything peculiar, is index.html. But it could also be index.jsp, the Java server, or index.asp if it's a .NET server, right? Or index.php, if it's a PHP server. Right? Some servers might be also configured to listen for home.html or home.php or whatever, right? Servers can be configured differently. That's a system administrator task, right? To configure the servers, right? Typically, out of the box, they should all be configured to listen to respond for index if you don't ask for anything in peculiar. Okay. So here's my page. What I want to be able to do here is say that this is going to be a to-do list, right? And what I want to be able to do here is create, maybe have like a little form that allows us to submit a new task, right? A new to-do. So let's do that. We'll have maybe an input field, and a button. And the button says maybe new to-do. Right? So if we re-render that, so we have to-do list, right? And we have a button and some text. Looks ugly, but we can always paint it nice. And we can do a placeholder maybe here. Placeholder allows us to give some clue on what it is that we're asking for, right? So we'll say name, task, or to-do name. Just to have some placeholder to give a clue on what do we want. Right now, it's not doing anything, right? It's not doing anything. So we want to be able to, let the user actually interact here, right? So how can we do that? So we're going to be using the mean stack framework, right? And mean stands. It's an acronym that stands for the following, right? So it's mean. JS and for Node.js. Okay, those are the 4 technologies. Well, really 3 plus 1 technologies that we're going to be using, right, for as a stack, right? A lot of people say that mean is not really a stack, right? It's not really a framework, right? A framework works together. They know about each other, right? And what you do in one affects the other. These are actually 3 different technologies, Angular, MongoDB, and Node.js, that don't really know anything about each other, but they just work very well with one another. Okay? In a real framework, right, if you do something in one part of the framework, it spreads over the entire framework. There's a particular naming convention, right, that that we have to follow, a particular way of a program that we have to follow, that is a part of the programming in that particular framework. Here, a lot of things that we're going to do is that we're going to follow a lot of conventions, like industry conventions, right, that everybody has agreed on as a community, as opposed to imposed by the framework. Right? The framework doesn't really care. Right? Obviously, when you're working in Angular, you have to follow the Angular framework. Right? And when you're Node.js, you have to follow the Node.js framework. Right? And when you're MongoDB, you have to follow the MongoDB conventions. Right? Well, I have them all work together. We're going to follow industry. Here have come up with best practices, right? It's not being enforced by an overall arching framework. Makes sense? Right? Each framework imposes their own little thing, but there is no overarching framework. Yes? It's just conventions that we're going to come up with, that the industry has come up with. All right, so let's create our very first Angular application. For that, we're going to have to download an Angular the Angular library, download, or better yet, we can point to it through a CDN. So CDN It's a content delivery network, right? For providing content, whatever those are, images, video, PDFs, JavaScript, CSS, right? And they're pretty much guaranteed to be up all the time, right? To give you a very good response, right? And that's their all reason of being, right? It's providing this content, whatever the content is. In this particular case, this is Google's developers CDN that has all sorts of libraries in here. So we have AngularJS. I'm just going to copy this. All right, and I'm going to paste it here. Right. Notice that this is going to Google APIs, which is of 1x, right? 157 is downloading a minimized version of the JavaScript library, right? Minimize again to make it as fast as possible to download these libraries, right? And you might say, well, why host it ourselves? Right? Why don't we copy that, right, and host it in our servers? Well, because this particular CDN is definitely guaranteed to be much more popular than you, meaning thousands of other developers are using that CDN, right? Chances are that by the time they get to your puny website, they have visited many more other websites that are using the same library, right? So by the time they get to you, it's pretty much guaranteed that that particular already downloaded, right? It's already in the user's, in that client's Java browser that they already downloaded. So the browser is not going to waste time downloading it, as opposed to coming to you the very first time. Is, oh, what's this new JavaScript file? Right? It's going to download it unnecessarily because it's probably already downloaded from Google, right? And it just wastes time. Right? It might not be a lot of time. But when you think that we're downloading Angular and jQuery and Bootstrap and all these other libraries, it adds up. Okay. Nevertheless, it's best practice, right, to use CDNs as much as possible. As a developer, when I'm developing, it's better for me to have it locally on my machine, right? Because I might not have a network connection, right? I might be on the train, working on the train, and I don't have access, right? Also, when it's copied locally, it allows me to debug it, right? I can step through the code, right? But when it's deployed, right, and ready for, landing in production, the best thing is to have a CDN. Make sense? All right. Also, I'm lazy. I'm not going to download it, right? So I'm pointing it to CDN. All right. So that has downloaded. Let's make sure it has downloaded. I'm going to refresh, right? One way to check is to look at inspect. Inspect is going to be your new best friend. So the inspector allows you to see what's going on. How is the browser interpreting this page, right? How is it interpreting the HTML? How is it interpreting the CSS, the JavaScript, right? The browser makes a mental model of what it downloads, okay, and reinterprets your page. If you have a broken link or you open the tag and you didn't close the tag, right? The browser will reinterpret that and make its best guess of what you meant. The computers are pretty bad at interpreting our bad way of speaking, right? I always joke that I hate computers, that they always do exactly what they're told. Okay, not what I mean, but what I tell them to do. They do exactly what I'm told. But if I screw up, they take things literally. Browsers are very good at interpreting what you meant. Okay, if you forgot to close the tag, they'll close it for you. Okay. So here in the Elements tab, we have what the browser interpreted what your HTML says. Okay, if you forgot to close something, or you forgot a required tag, it'll add it for you. Okay, so it says that you have in the head, you have the script, you downloaded it. In sources, you can see all the things that were downloaded. Okay. You notice that it says from Ajax, Google API, JS, it downloaded the library. There it is, Angular Min. It's meant for interpretation by the browser, not by human beings, right? There's a minified file, right, that has removed all white spaces, right, and renamed your variables. Locally, I don't have any other JavaScript here, so I don't have any other source. Network, if I refresh, it'll, why is it not showing? What's going on? Network? I don't know what's not showing it. Oh, where's, oh, do I have a filter on? Oh, thank you, yes. So this shows all the various things that were downloaded and how long it took to download each thing, right? So again, this is your best best friend. You can look at the source, your source, and you can step through the code. You can put breakpoints, right, and debug it. What's going on in the browser? Please become familiar with it. So anyway, so to create our very first Angular application, we're going to say ng app. Right? Ng app, as you might know, this is all these over here. Notice that we have name value pairs, name equal to value, name equal to value, name equal to value, right? All these are attributes. Angular allows you to do is to create your own attributes. You don't like HTML? You can redefine the entire HTML language, right? You want ordered list to render as unordered list. You want to images to render as paragraphs. You want to redefine HTML. You don't like HTML. You can redefine the entire language. Angular allows you to redefine or create your own tags. You want a new tag that's not there? You can create your own tags. New tags with new attributes with new everything, right? And then associate those tags to code, right? That actually implements those things, right? So Angular, out of the box, they are Angular's attributes because they all start with ng dash, right? So that you can create your own, right? If I create my own, I would put JGA dash in front of it, so it has my three-letter initials, right? Or if you're working for some other company, you might use that, right? To namespace, okay, right, to distinguish between something that you created or something that you were using from someone else, right? It's always a good idea to create a namespace, right? It says, oh yeah, I wrote that, right? As opposed to, wait, where did this come from, right? One of my peeves from Bootstrap is that they do not namespace any of their classes. So I never know if is this a Bootstrap class or is this something that somebody wrote this other class, right? But for you, please namespace anything you create. Anyway, ng app, we'll give it a name. We'll say ToDo app. Okay, and we'll need a script that implements our application, and we'll write it under here. We'll say it's under app.js. Okay, so we're saying our implementation of our application lives in this other file called app.js. Yes, and we can create it here. We can say public new JavaScript and say app.js. So this is our very first JavaScript file we're going to write. Okay, and the way this works is that here's a library. It loads, right? What Angular does, right, when it gets loaded like this, it parses the HTML. It parses the entire HTML and it becomes aware of itself. And starts parsing it. And for instance, it finds that there's a attribute over there called ng app. It says, oh, okay, this is one I know, right? That means that somewhere there must be a declaration of a Angular application called ToDo app. Let's look for it. Where is it? If it doesn't find it, it'll complain. I can't find it. It's nowhere. Where do we declare it? We're going to declare it, for instance, in this app.js. So let's go there. Let's declare it. Okay. And so one of the other things that Angular does is it declares one single object, a global object, right, called Angular, right? This global object allows you to create right? And so it's a very magical object that has lots and lots of really useful functions. Right, you can say Angular. Angular is an object that is declared globally. That's why I can reference it here. Right? And one of the things that I can do to declare a module. Module allows you to create all sorts of, break up your applications into many different modules that you can then bring together and build up, to build an entire application, right? There is a root module, right? The module that is, the owner of all of the other modules, okay? From where the whole thing starts, right? Here's where you can declare the module, ToDo app. Notice that this ToDo app, oops. ToDo app right here. See that? So these are intimately linked to one another, plus any other modules that we might depend on. Okay. Right now it's a simple app. We don't depend on anybody. We're not depending on any other modules. So we put the empty array. But the empty array is required. If this is a top level module, right, you need to put the empty array in there. Otherwise, it won't work. Okay. And I think I've reached my time limit. It's what it's 1:25. All right, we'll pick this up on Monday. The video should be available later this afternoon if you want to take a look at it. Right, take a look at the setting up the environment. Download Node.js, MongoDB, set that up. You can go on. All right. All right. Thank you.